Okay, hello everyone, and welcome back to your YouTube channel. Yes, this is your YouTube channel because we are creating those videos for you. And today we have a very exciting video. I have been thinking about this video for quite a while, and I decide it's time to record this video and mainly answer one very important question. Do we need signal conditioning devices when we are running hardware in the loop and real-time simulation? And the first part of this video, I dedicate the first part to answer this question with few reasons. And then what I will do is I will do a workaround around the amazing device, the Typhoon-HIL Connect. Well, but before I start, I would like to say thank you very much to Cell for the strong collaboration and support, and also thank you very much to Typhoon-HIL for the collaboration and all the support provided by the team. Thank you very much. Um, I would like to start this video with a short introduction about what was the reason for recording this video. Few weeks ago, I put this photo, the photo that is on the left-hand side. I put this amazing photo at my LinkedIn. And then I start to receive many comments and so on and questions. And I decide it's time to make a proper explanation. I put that photo on my LinkedIn on a Friday night after a very exciting results. I was testing the Cell 751, the feeder protection relay from Schweitzer. I was doing what I call relay in the loop. I have a small power system inside the real-time simulator. Then I use the signals created by the real-time simulator, and I amplify and modify those signals in order to be fed into the cell relay. And in that moment, I was testing the under frequency protection function in this feeder relay, the 81. And I create the under frequency event using this real-time simulator, the Typhoon-HIL. Well, the history is I published that photo and it was quite attractive for many people and very interesting question appear. However, right now I decide it's time to show you a bit more about that Friday night. Right now you can see the full setup. Of course, it was not similar like this, but on the top you can see the feeder protection relay, the Schweitzer, the Cell 751 that was under test. And inside this HIL 604, Typhoon-HIL 604, the real-time simulator, I had a power system that was creating the under frequency event. Then, using the digital and analog inputs outputs, I sent to this big element over here, the HIL, the universal HIL Connect, in order to conditioning the signals to this relay. Well, that was the test, and then I received many questions, and I decide it's time to explain a bit more about using signal conditioning devices when you are using real-time simulation or if you are doing a relay in the loop. But the question is, do we need signal conditioning device when we are using hardware in the loop? Well, let's start the answer. Let's start the answer with some very basic background. Um, we electrical engineers, power engineers, time to time we face a challenge and is testing a real device, a power device. When we are testing a power device, a real power device, of course we need power. And that was the motivation behind the concept of power hardware in the loop, or PHIL. Power-HIL. Power hardware in the loop has been used for quite a while, but basically is a chain that we have the workstation, we have a real-time simulator, and then the real-time simulator is creating low power signals and going to this device over here. In this case, that is a signal conditioning device that allow to amplify the signals and send the signals to the actual physical device under test. In this case, could be a protection relay. That Friday night was the Cell 751, okay? And however, when the device is working and produce signals, of course, those signals are going back and closing the loop. And this signal conditioning device, of course, have the possibility of receiving analog and digital inputs and then send back to the real time simulator. As a consequence, if you are doing power hardware in the loop, of course, you will need a signal conditioning device, okay? If you are doing power hardware in the loop, of course, you will need these kind of devices, these signal conditioning devices. I am saying this because a few of my colleagues approach to me and they say, okay, but you can run also low power signals. You can use low power signal to test some relays. And I can say yes. If you are interested on having low level test, low power test, you can do that. Because, for instance, this HIL 604, this real-time simulator, it has the possibility of providing signals, analog or digital, inputs and outputs with a range from minus 24 volts to plus 24 volts. As a consequence, if you want to try or you want to use a low-level test in your protections, that is a realistic option. In fact, here I would like to show you Cell Twicer. They provide you information in the user manual of the relay if you can perform this kind of low-level test. In fact, for instance, I can show you here the Cell 411L. If you go inside the user manual, the instruction manual, you will find a section explaining the low-level test interface. You can go inside the user manual and Schweitzer is giving you all the steps. I put over there only 5. There are 7 steps in the user manual and you can perform your load test. However, something that you must be aware is that in order to get access into the low-level test interface, you must open the relay. And of course, you need to do some procedures. And those digital electronics devices, they are quite sensible for electrostatic discharge. For that reason, you must be very careful when you are performing this low-level test interface, okay? Schweitzer also include all the pins and all the requirements that you need to take care of when you are performing this low-level test interface, okay? Here I have a photo. As you can see, somebody opened the relay, somebody make a connection, and as consequence, you can see that that is a possibility. My friend Luigi Banfretti provide me this other photo over here. This is a beautiful setup that he has that is using the Cell 311L. And as you can see, they have a very organized and very beautiful setup where they are making low-level tests. I have very good discussion with my friend Luigi Banfretti about using low-level tests, especially when you are working with the students and you don't want to expose them to high voltage or high currents. However, my personal decision is some tests are better if you can perform if you can perform the test using the appropriate level of voltages and current. And in some cases, that is the only solution. I mean, as I said before, some relays, they can be tested using the low level interface. However, something that you must realize is when you are doing that, you are not taking in account the dynamic or the performance of the analog digital converter. For that reason, there are many applications that you cannot use the low level interface. If you are if you are assessing the whole relay as the entire device, of course you need to apply the appropriate level of voltage and currents, and power hardware in the loop is the only solution. And also there are some situations that the only solution that you can use is using power hardware in the loop. Wow, and now what I will do is something very interesting. Right now, I will explain to you what was the hardware, the the signal conditioning using the signal that we are using at the lab. And at this moment, I will told you about the Universal Hill Connect. To be honest, I am really surprised about this device, okay? This is as strong as an elephant, okay? I was surprised. This is big, this is huge, but this is powerful. Um, the Universal Hill Connect is something that is making very simple to perform power hardware in the loop. Okay, right now, as you can see, I am showing the setup that I have at the lab. We have a workstation connected to the real-time simulator, in this case, a HIL 604, and then we are going to the Universal Hill Connect. From there, we have high power and low power also, digital and analog signals, and we can receive them. To be honest, the Hill Connect is an amazing device. It's a signal conditioning device that allow you perform power hardware in the loop in a very simple way. Why? Because this device is adapted, is designed for this kind of activity of protection relay in the loop. And as consequence, the device is already adapted to the standard inputs and output coming from real relays. However, this device can be used for more than that, okay? If you need to use the signal conditioning for other kind of signals, this device is able to do it, okay? Well, what I will do now is a very short walk around on this device, okay? And what I will do is I will show you the device. This is another photo that I published on social media. This is the HIL Universal Connect. The HIL Universal Connect is a very big and strong device. Inside this device, I was surprised about the power electronic devices inside and all the electronics that you have. Inside this device, the device that I showed you in the photo, at least we have eight electronic cards, two of them dedicated for high voltage outputs. I will tell you about the levels in a minute. There are two specific cards dedicated for high current outputs. And then we have cards, electronic cards, dedicated for analog inputs and output and digital inputs and output, okay? What I am showing here on the right-hand side, is basically a X-ray, what is inside this device. Inside this device, you will find the 8 boards, and you can see here 2 for high voltage, 2 for high currents, then we have the analogs and we have the inputs. But the clever thing here that is making easy to perform the power in the loop, the power hardware in the loop, is that the inputs of this big signal conditioning devices, these signals are coming from a format that is already predefined by the real-time simulator from Typhoon-HIL. What I'm trying to tell you is that the front view of this device, is quite simple to see that there are two main connectors. If you look over here, this is the photo that I show you. This is the front panel of the Universal HIL Connect, and you can see there are two connectors. The the left-hand connector is dedicated for the analog inputs and outputs, and the right-hand side is dedicated for the digital inputs and outputs. The front panel is dedicated for this interface that represent the low power interaction with the real-time simulator. What I'm trying to tell you is those connectors are going directly connected to the real-time simulator. And Typhoon-HIL is using a 96-way connector, the DIN 41612, and that is the connector, the standardized connector that you can use to, from here, connect to the real-time simulator and make easy the communication between the real-time simulator and the Universal HIL Connect. Then I will go to very exciting part of this Universal HIL Connect. Right now we are looking the rear view, the rear panel of this Universal HIL Connect. As I said before, there are two cards dedicated to high voltage outputs. And the amazing thing here is Typhoon-HIL is offering you two connectors for each high voltage card, and they call slot A and slot B. Each connector is a very simple A-pin connector, and as you can see, they are providing you four signals for each connector. In this case, you are able to use those connectors using plus and minus 183.3 volts. What I'm telling you is if you are using AC signals, you can use a peak value of 183.3 volt as a maximum. And the Universal HIL Connect is providing to you a total of 16 of these outputs. But very important information is that those signals can be used to recreate the performance, starting from signals in direct current up to 10 kilohertz signals. For that reason, you can use the Universal HIL Connect to reproduce the most important and typical power system phenomenon because the bandwidth allow you to do so. And also, as you can see, the accuracy of these signals is below 1%. And as you can see, those signals can be used, for instance, as I did for a protection relay. Then we have two more boards that they call a slot C and a slot D, and those boards are dedicated for the high current output. And in this case, the Universal HIL Connect offered you 16 high current outputs with peak value, a maximum instantaneous current of 2.82 amps. And again, this device is able to provide signals with a bandwidth starting from direct current DC up to 10 kilohertz. And in this case, we have an accuracy of 0.1%, okay? But probably you are wondering why this gentleman is so excited about the Universal Hill Connect. Well, I am really excited about this because if if you look the Universal Connect device is basically a hardware, and this hardware is allow me to produce, for instance, voltages and currents that I can use for testing some of my wide area monitoring and protection algorithms using real protection devices like, for instance, the Cell 411L. This universal connect, the Hill Connect, is able to provide to me signals in voltages and currents with the appropriate values to perform real tests considering the whole relay, the cell 411. But also this Hill Connect is able to receive digital and analog signals. And those digital signals, for instance, they can be used to retrieve information from the relay, but also send signals to the relay like open, close, or some many other functionalities that you can use. And this universal hill, of course, is receiving and sending signals to the real-time simulator and then to the cyber environment. And Typhoon Hill have the SCADA system, the software that is allow me to communicate with the hardware in the loop or power in the loop, hardware in the loop components. And what I noticed from my experience is that using the SCADA system, you are able to easily configure the outputs and inputs of this Hill Connect. It's making my life extremely easy, the configuration of every single input and output of this signal conditioning device. That is the reason that I am really excited about this device. Well, right now it's a very exciting time because in front of you, you must have a look of the two very important components when you are performing power hardware in the loop. And in front of you right now, what you have is basically the real-time simulator on the top. And as you can see over here, this is the HIL 604. That is the top of the line of the real-time simulator from Typhoon Hill. In this case, this device is the real-time simulator that I say to you I use for simulating my power system and produce signals, low power signals for testing my relay. As you can see over here, you can see at the front there are four connectors. To the left-hand side, you will have the connector for the analogs, inputs and outputs. And on the right-hand side, as you must be aware, those are dedicated for the digital inputs and outputs. And below, you have the start of this video. Today, you have in front of you the very strong and powerful Universal Hill Connect, okay? As I say before, the front panel of the Universal Hill Connect is extremely simple, extremely beautiful, a lot of lovely aluminum finish. I like it. And here in the center, you can see that there are two connectors, one of them dedicated for the analog inputs and outputs, and the other one dedicated for the digital inputs and outputs, okay? The good news is those inputs and outputs, those connectors, they match perfectly the connectors coming from the HIL 604. For that reason, it's very, very simple to create the connection between the real-time simulator and the signal conditioning device. And here, as you can see, I have the full connector. This is the connector that we need to use when we are interconnecting, of course, the HIL 604 to the universal HIL Connect. And those connectors, they are very, very simple to install. What you need to do is connect over here, okay? And then what you need to do is going down to this device, and then you connect on the right, on the HIL universal, okay? Of course, those connectors, they have a screw, and those screw, they are designed to make secure the connection, and you can make the connection here and there using the screw, of course. And I will not do this because I will remove in a minute, but there is a connector coming from the real-time simulator to the universal HIL device. And for the digital signals, we can do the same. There is a connector coming from HIL, and you can put over here the connectors, okay? I will not connect those devices over here because I will remove, because my job today is talk about this beautiful device over here, this beautiful HIL Connect device, okay? As you can see, it's very simple but beautiful. You can see the power switch and also LED indicating that the device is on. However, for researchers and people like me, probably we are more excited to see the back or the rear side of this universal HIL Connect. And that is what I will do, okay? As you can imagine, this strong and powerful device is a bit heavy. For that reason, what I will do is I will record the backside in a minute. Okay, this is the most exciting part of this video because right now I am showing you the rear view of the Typhoon Hill Connect, okay? As you can see over here, there are many connectors, and starting with the first one, this is the power plug. This is the connector that we use to supply power to this very strong Hill Connect. As I say before, this device has 8 cards inside, okay? And they call slot A, B, C, D, and then you have 4 more, okay? I will not open this device, but they install here. You can see through these small small holes over here. You can see that they are the 8 cards that we are talking about, okay? The 4th slots on the left-hand side, they are dedicated for high voltage and high currents. As you can see, slot A and B, you can see the symbol here. We have high voltage because in those terminals over here, we can reach up to 183.3 volts, instantaneous volts, okay? And on the left-hand side, this 4th slot over here from E to H, you can find the connectors for the digital and analog, okay? What I would like to show you, what I want to show you is that this device, the 2 important connections over here, they are dedicated for high voltage, as I say before. And Typhoon Hill thought about this, and there are some connectors that you can use. As you can see over here, it's very simple. It's extremely simple to connect the connector, and as you can see, it's very simple to wire your power hardware in the loop test bed. It's extremely simple. They are very simple and robust connectors. As you can see over here, we are using 8-pin connectors for each one of those ports that you have here and the back, okay? As you can see, they are all the same for the high voltage and high currents. However, each connector has defined a very specific point. In this case, this is the specific port is the X17, okay? On the other hand, for the low power signals, low power signals located here on the right hand side, uh, mm, Typhoon-HIL is using a very interesting and very useful connector. As you can see over here, the connector is very simple and there are many points of connection over here. You can see all the cables, and the important part here is that the connector is extremely simple to connect again, and is very simple for you wiring your power hardware in the loop in a very basic sense, okay? Well, it's very simple to connect and disconnect, and also very simple to keep tight your wiring when you are implementing your lab activities, okay? Well, this is the back of this very strong and beautiful device. This is the back or rear view of the Hill Connect. And I hope you like this video. I hope that you understand why it's really important that we use these kind of devices. It is time to finish this video. I hope this video helped you to understand what the concept of a signal conditioning device is, how this concept is connected to power hardware in the loop, and also that you understand how important is having those devices when you are working with real power devices. Finally, as I did a workaround on the Typhoon-HIL Connect, I hope you was able to see all the features of this device, and I hope you enjoy the video. Thank you very much for watching. I will see you in the next video. Thanks.